Everybody, my dear mathematics section students, our lecture today is about center of gravity, part 2, surface element. This lecture is introduced in the period of coronavirus spread. God save you and save our dear country. Firstly, we should take some remarks to solve some different examples about center of gravity. First, center of gravity is given by G, X bar and Y bar. We notice that we can find X bar by using the rule X bar equal definite integral from a to b x e dm over definite integral from a to b dm, and Y bar equal definite integral from a to b y e dm over definite integral from a to b dm, and dm is the mass of element. To solve any example on center of gravity, we should know xe and ye, position of the element, and type of dm, and limits of integration a and b. Now, we should know types of elements and its densities. Firstly, we talk about length element, which given by dx or dl. dx in case of rod and dl in case of other curves. And its density is given by lambda. And also surface element. Surface element is given by ds, its area of the element. And its density is given by sigma. We solve or using it in examples of area bounded or lamina or plate. And volume element, we use dv, that represents the volume of the element, and its density is rho. Next, we should to find mass element. Mass element gm. Firstly, for length element, gm equal lambda dx for rod all, or lambda dl for any curve. For surface element, gm equal sigma ds. For volume element, gm equal rho dv, and lambda, rho, and sigma are constants. 3. How to draw graphs. Firstly, for the curve x square equal ay, relation between x and y, and one of them of the second degree and the other of the first degree, that represents parabola, which is symmetric about y-axis or the first degree. Y is of the first degree, so the curve is symmetric about y. The other, y square equal ax, relation between x and y. One of them y of the second degree and x of the first degree, so it represents a parabola, which is symmetric about x-axis, where x is of the first degree. Like this. Third, the curve y equal sine x. Sine x, it's a periodic function, but it's from x bounded from 0 to pi. 0 to pi. It's a curve of sine x and above of the x axis in positive direction from 0 to pi. From 0 to pi. Now, how to draw lines. First, y equal a. We have y equal a. It's line parallel to x-axis and cuts y-axis in point 0 and a. This is the line. And cut y-axis in point 0 and e. x equal h. It's line which is parallel to y-axis and cuts x-axis in point h and 0. Parallel to y-axis and cut x in point h and 0. Now we will talk about surface element and its position. Surface element and its position. We have three cases. First, its area bounded by the curve x square equal y and y axis and line x equal a. How to draw this graph? Firstly, x square equal y, it's parabola which is symmetric about y axis, right? Y axis. Now y axis is this line x y equal a, yes, this line. Then the area bounded between them, it's the area bounded. So we want to find center of gravity for the area bounded by the y axis and y equal a and the curve x square equal y. Firstly, we should take an element like surface element that we have area, the k area, so we deal with surface element by taking surface element like sin root with dimensions x and dy, then gs, which is area of the element, equal x dy, length times width. So we notice that if the length of the element is x and width is dy, as shown, we should have dx or dy. If one of the graph is y-axis, then we have dy. Or if one of the lines is x-axis, it's x-axis, that. So we have dx. If one of the lines is y-axis, so we have dy. If one line of this is b y-axis or x-axis, we have dx, and so on. Now we find ds. ds equal x dy, where using ds we can find gm, which is equal to dm equal sigma times gs. Now we should determine the position of the element by taking point in the middle of the sin of this root. Then we take point in the middle of the element, so it's middle of length x, it's x over 2. This length divided to two parts, x over 2 and x over 2, but this length still y. So if the element is parallel to x-axis, its position of the element xe and ye is x over 2 and y. If the element is parallel to y-axis, then the position of the element xe and ye will be x and y over 2. Now xe and ye will be x over 2 and y. X over 2 and y. Limits of integration. This element is bounded from y equal 0 to y equal a. then the limits of integration will be y between 0 and a. Number 2, area bounded by the curve y square equal x, relation between x and y, one of them y is of the second degree and x of the first degree, so it is a parabola which is symmetric about x-axis, and that's x-axis, that x-axis, and line x equal h, this is the curve. So this area which we want to find the center of gravity. Firstly, we will take a surface element which is like thin root with dimensions y and dx. So we can find ds, area of the element. It's equal y dx. To determine the position of the element, we notice that its point in the middle of the rod. So its middle of the length y. It will be x and y over 2. Limits of integration. To find limits of integration, these elements is bounded by point 0 and 0 and point h and 0. So x is between 0 and h. It's limits of integration. 3. Area bounded by the curve y equals sine x. And x bounded from 0 to pi. And x-axis and curve of sine x from 0 to pi. We should take a surface element, thin root with dimensions y dx, and its area is ds. So ds equal y dx. To find the position of the element, it will be point in the middle of this rod, so it will be x and y over 2. And limits of integration will be from 0 to pi, which is given in the example. Now we will take some examples on center of gravity surface element. First example, find the center of gravity for the area, then gm equals sigma gs, bounded by the curve x square equal y, it's parabola which is symmetric about y-axis, and y-axis, and line y equal a, as you see in the graph. By taking surface element, we know that taking surface element like thin rod, which dimensions x and dy, so ds equal x dy. Using ds, we can find mass element gm as mass element in this case equal sigma gs. So gm will be sigma ds and sigma xgy. Second step, we should find the position of the element. We will put point in the middle of the rod. It will be x over 2 and y, that is xe and ye. And we can note that limits of integration will be from 0 to 2a. Limits of integration from 0 to a. To find center of gravity, finding x bar. Firstly, x bar equal definite integral for xe gm over definite integral of gm. xe is equal x over 2 and gm equal sigma x dy and over definite integral from 0 to a sigma x dy. We can cancel sigma by sigma. So we will have 1 over 2 integration for x squared dy over integration for x dy. We can't solve the integration x due to dy. So we should convert x squared to y. X squared equal ay, which is given, it's the parabola. And we can find x equal root x y root a y power 1 over 2. So we can write x bar in the form 1 over 2 x squared replaced by ay and x replaced by root a y power half. We can find this integration. That's y will be y squared over 2. Y power half will be y power 3 over 2 over 3 over 2. Now 2 times 2 equal 4. Then it's equal a over 4. From 0 to a, 0 will equal 0. So we replaced y by a. It's equal a squared. This will equal 2 over 3. 2 over 3 root a. 2 over 3 root a. Replaced y by a. It will equal a power 3 over 2. A squared times a equal a cube. A power 3 over 2 times root a, which is equal a power half. So it will equal a squared. A squared, a cube over a squared equal a. So x bar will be equal to 3 over 8a. Finding y bar. Y bar equal definite integral from a to b ye dm over definite integral from a to b dm. So ye equal y and dm equal sigma x dy and also dm equal sigma x dy. You can cancel sigma by sigma. We can do this integration x with respect to dy. So we can find x as x squared equal ay. We can find also x equal root a y power 1 over 2. It will be y x equal root a y power half and x equal root a y power half. We can cancel root a by root a. This equal y power 3 over 2. The integration, we can adding 1 to the power and dividing it about over the new power. It will be y power 5 over 2 over 5 over 2 from 0 to a, and y power half will be y power 3 over 2 over 3 over 2 from 0 to a. We can cancel 2 by 2 and it will be 3 over 5. 3 over 5. From 0 to a will be a power 5 over 2. and this from 0 to a will be a power 3 over 2. A power 5 over 2 over a power 3 over 2 will equal a. Then y bar equal 3 over 5a. So center of gravity in this case is given by g x bar and y bar equal 3 over 8a and 3 over 5a. The second example, example 2. Find center of gravity for the area. Then we have gs and dm equal sigma gs. We will take a surface element. The curve y square equal 4ax. Relation between x and y, one of them y is of the second degree and x is of the first degree, so it is a parabola which is symmetric about the first degree, so it's symmetric about x-axis. And x-axis, this x-axis, and this is the curve, and line x equal h, this is line. So this area bounded that we want to find the center of gravity. We will take a surface element like a thin rod with dimensions y and gx. So the area is gs equal y gx. To find mass element gm equal sigma gs. So gm equal sigma times y gx. Now we want to find the position of the element. We put a point in the middle of the element. It's middle of length y. So xe and ye in this case will be x and y over 2. And if we want to find limits of integration, this element is moving between 0 and h, which is the limits of integration. X between 0 and h. To find center of gravity, finding x bar equal definite integral from a to b xe dm over definite integral from a to b gm. Xe in this case equal x and gm equal sigma y gx, and also dm equal sigma y gx. Now we can cancel sigma by sigma. So we have integration from 0 to h, xy gx, y gx. We can solve this integration. We can solve integration with respect to x due to y. So we should find the value of y in terms of x. We have that y equal 4ax y squared. So we can find also y, that y will equal to root a x power 1 over 2 to solve this integration. As you see, y squared equal a 4ax, then y equal to root a x power half. Now we can cancel 2 root a by 2 root a. This will equal x power 3 over 2. This integration will be x power 5 over 2 over 5 over 2. And this integration will be x power 3 over 2 over 3 over 2. Now from 0 to h, we can cancel 2 by 2. It will be 3 over 5. This will be h power 5 over 2, and this will be h power 3 over 2. All of this will equal h. Then x bar equal 3 over 5 h. Now, to find y bar, we notice that y bar equal definite integral from a to b y e gm over definite integral from a to b gm. ye in this case equal y over 2, and gm we know that equal sigma y gx over sigma y gx. We can cancel sigma by sigma. Now it will be half y squared over y gx. We also can solve this integration, that y gx. Now we should put or replace y by terms of x. We note that y squared equal 4ax and y equal 2 root a x power half. Now it will be this case 2a, this equal 2 root a. Integration for x is x squared over 2, and integration for x power half is x power 3 over 2 over 3 over 2. 2 by 2 and root a, then a will be root a, as a equal root a times root a from 0 to h. Now it will be root a over 2, and this fraction will be 2 over 3. This will equal x squared, and this will equal h power 3 over 2. Now we notice that 2 and 3, it will equal 3 over 4 root a. 3 over 4 root a. H squared over h power 3 over 2. This will equal h power half. H power half. Now h power half equal root h. Taking this inside root a, it will equal root a h. So y bar will equal 3 root ah over 4. Now we have center of gravity, which is given by 3 over 5 h, 3 over 5 h, and 3 root a over 4 h. Example 3. Find center of gravity for the area bounded by the curve y equal sine x, and x is bounded is from 0 and by, and x-axis. Now y equals sine x from 0 to pi. It's the curve of sine x from 0 to pi. The element bounded from 0 to pi, and we have x-axis, so we have gx, and the element is parallel to y-axis. We will take a surface element like a thin rod with dimensions y and gx. In this case, gs, the area of the element, will be ygx. Now we should find mass element gm. Mass element gm in this case equal sigma gs, so it will equal to sigma ygx. We want to find the position of the element xe and ye. We put point in the middle of this rod, so its middle of y, it will be x and y over 2. That is equal to xe and ye. And limits of integration is given in this example from 0 to 2 pi. To find center of gravity, to find x bar, firstly we write that x bar equal definite integral from a to b xe dm over definite integral for gm. xe in this case equal x and gm in this case equal sigma y dx. Now we can cancel sigma by sigma, so we have integration from 0 to pi xy dx over integration from 0 to pi y gx. We can solve this integration, that's y dx, so we can replace y in terms of x from the curve which is given y equal sine x. So x bar will be integration x sine x dx over integration sine x. Let it will be equal to I1 over I2, and this relation is star. To find I1 equal definite integral from 0 to pi x sine x gx. This type of integration we can do a simple test that the angle of sine is x, its first derivative is 1, not equal x, so x and sine x be two main functions. We should use integration by parts, so we will use integration by parts. Let u equal x, so du equal gx, and dv equal sine x dx, so v equal negative cosine x. The rule of integration by parts is uv minus integration v du. So it will equal to negative x cosine x, negative it will be positive v du, that's definite integral from 0 to pi cosine x gx. Now let x one time equal pi and another time equal 0. First it will equal negative pi cosine pi negative or positive 0. Cosine pi equal negative 1. Negative 1 times negative pi, it will equal pi. Sine x from 0 to pi, sine pi equal 0, sine 0 equal 0. So all of this equal 0. Now we know that I1 equal pi. Did we see? Sine pi minus sine 0 all equal 0, then I1 equal pi. To find I2 is definite integral from 0 to pi sine x dx. Integration for sine x equal negative cosine. So it will be negative cosine x from 0 to pi. First by x, we put x by and put x by 0. So it will be cosine pi minus cosine 0. Cosine pi equal negative 1, cosine 0 equal 1, negative 1 equal negative 2 times negative 1, then it equal 2. So I2 equal 2. We from 1 and 2 in star, we have x bar will be pi over 2. To find y bar, we put ye by y over 2 and dm by sigma y dx over sigma y dx. We can cancel sigma by sigma. So the integration will be half integration for y squared gx over integration y gx as follow. But we can't find integration with respect to x in terms of y. So y squared gx, we should replace y by x from the given curve. Y equals sine x. So it will be sine squared x and this will be sine x. Let this integration equal I3 over I4 and this relation is double star. To find I3, half definite integral from 0 to pi sine squared dx. We notice that from calculus 2, sine squared and cosine squared we can't find its integration in direct way. So we convert it to another form to find its integration. Sine squared, by using double angle for cosine, it's equal 1 over 2 brackets 1 minus cosine 2x. So sine squared and this integration will be half definite integral from 0 to pi half 1 minus cosine 2x gx. 1 over 4, 1 it will be x. Integration for cosine 2x equal to sine 2x over 2 from 0 to pi. One over 4 x from 0 to pi will be pi minus 0. 1 over 2 sine 2x, replace x by pi, then it will be sine 2 pi minus sine 0, all equal 0. Sine 2 pi equal 0 and sine 0 equal 0. So I3 equal pi over 4. To find I4, I4 is definite integral from 0 to pi sine x gx. We have two ways. We can solve it in simple steps, but we find it in x bar. In x bar, we find the same integration in I2, integration from 0 to pi sine x dx. So we can put I4, which is equal to I2 equal 2. Then I4 equal 2. From 3 and 4 in double star, y bar will equal pi over 4 over 2. So y bar will equal pi over 8. Now we have x bar and y bar. X bar which is equal to pi over 2 and y bar which is equal pi over 8. So center of gravity for this area is given by x bar and y bar equal pi over 2 and pi over 8. That's all. Thank you.